Welcome all. So, in this lecture we are going to talk about how the total station, or we can say the other than the total station, we use RTK, that is real time kinematics, to map the landforms, and this is one of the most important part wherever whichever terrain you take, or maybe the aspect. Even in the civil engineering we need this type of mapping, but in particularly earth sciences and the geology we take, or we can say geomorphology, where we are dealing with the surface morphology or surface topography, then we need to go for this type of mapping. And nowadays this precise mapping, this type of precise mapping has been done to also understand the evolution of the landforms or the landscape in total, provided you have the edges. So, the followed lecture, maybe in one or two other lectures, we will talk about the dating part of the landforms. That means we will try to obtain the age of that landform and try to understand that how fast that landform or the landscape has evolved over the time period. So, total station will just give a brief explanation here, but this will be also, I would say, that attached with the lab, okay, where you will understand more about it. So, I will just try to give some brief information about the total station survey in landform mapping. Now, why digital mapping of the landform is required? As I mentioned briefly, detailed topographic mapping, it provides us a precise log of an outcrop in a few meters square to a million meter square area. Okay, you can extend this on a larger scale, but nevertheless I would like to mention here that nowadays this method also is slowly getting redundant, because the evolvement of science and all that, we have now moved to the mapping technique using aerial surveys by UAVs or drones. So, that again, but nevertheless this is not the point that we should ignore this type of mapping, because some locations we won't be able to fly, but so in that case you need to have this type of topographic mapping to be done by total station. So, precise mapping by measuring points, usually what we are doing is XYZ, or we also call this or you can call Z, and that is you are giving the coordinates. Okay. So, what we are doing is that we if suppose this is the point you want to measure on the surface, so you have your station here. So, with this station you are with respect to that north, or maybe the parameters which you have said, mainly we are looking at the coordinates. Okay. So, that is we usually call easting, northing, and then we have the elevation. Okay. So, that is you can say the slope of the terrain. So, basically we are looking at on an horizontal plane, we are measuring the angle with respect to this. Okay. So, this is what we will get the coordinates of this point here, and at the same time we also, if there is a topography here, okay, so then we also try to measure that what is the elevation of that. So, we are also measuring the angle, vertical angle, or we can also talk about the slope. So, we are usually using the two hemisphere, maybe we can say that this one is horizontal measurement as well as the vertical measurements we are taking, and that will give you the X, Y and Z. Okay. So, and the most important part here is that this measurements you will get in mm accuracy. So, millimeter accuracy you can do the mapping using high resolution total station. So, considering our goals and related techniques, surveying with the total station instrument is useful for measuring the followings. Okay. So, one is the topographic profiles and precise leveling. Fluvial landforms you can map where you will get the relative height of the terraces, offsets of the small scale fluvial channels, channel cross-sectional areas you can also extract if you have done the detailed survey of any region. Okay. Now, the point here is that you will get here the relative height. Okay. So, relative height usually we do if we are not requiring any precise like sort of an elevation change or so, then but we need to have an understanding that what is the relative height of any landform. For example, you are having like we usually we take the terraces. So, if you want to take that, then and this is your river bed. So, if this is your river bed, then with respect to that, what is the, so with respect to this one, what is the relative height over here? Okay. And with respect to same, what is the relative height of this point? Okay. And similarly over this here also. Okay. So, that will give you the relative height between with respect to your this thing, but at the same time if you want to have the precise height of any landform, then you can even use the benchmarks which are provided by the Survey of India, or because since we are having high resolution GPS antenna here, that is what we are using, differential GPS. So, that will give you with respect to the MSL. So, this also you can get. Okay. So, provided, and also the coordinates you will get with respect to the north, you will get that of a given particular point which you are measuring in the field. Now, coming to the other part, for mostly in our lab what we are using is that mapping of the landforms, and if you are having the tectonic landforms that is displaced by during an earthquakes, so that also we measure, and that what we call co-seismic rupture and associated deformation. Because for us that is, so for example, I will just explain here that if suppose there is the flat surface here and there is a fault which has displaced this later on during an earthquake, and then you see a such sort of in topography. Okay. So, there is a displacement here of this surface. So, this height is important for us. Okay. This height is important for us. So, if you have the age of this from somewhere from this portion of the sediments, then you can calculate that. Okay, fine, in a given years how old it is. Okay, and what is the height, that relation you can calculate the period of its uplift, that how many earthquakes were required to uplift that area. Even we can also map the terrace risers and fault scarps. Okay, but mostly you can focus what we are talking about is that topographic mapping of any given area, and that is related to the mapping. So, total station fundamentals, if we take, as I briefly explained, so we usually look at the parameters and calculations. Okay, and here the total station itself is a digital theodolite with EDM, that is your electronic distance measurement, and that will measure your will give you the coordinates, that is what we were talking about, the XY, and then it will also, the CPU within it will calculate even the angle between that. Okay, and will give you even the elevation depending. So, how it works, this is just a brief idea, and then how we take the points in field, that I will explain in following slide. So, this is the dissection of the total station. What we say nowadays, we are having the robotic total station. So, earlier what we used to do is that we used to place our total station at one point. So, this is your this is what we call the station. Okay. So, this has been stationed here, and then suppose we have such a topography here. So, we usually this will allow us to fire a laser. Okay. So, this will allow us to fire a laser, and there will be a post which is again it will be having a particular height, and then it will have a prism here. Okay. So the prism and then we have to focus this the center of this prism through this lens here, which has been shown here, and then we have to match the proper cross wires. Okay. So within the lens you will find there is a cross wire here, and that you should try to focus with the center of the prism here. So usually earlier what we used to do is that if you want to measure this point, then the person will move with the post and then move here, and that we will take the point here and will say record. So it will record the point, and then again the person will take the post here and then move on the second point, and again. So this required 2 persons. Okay. One is sitting here like, okay, and then another one is moving with the post. But now with the what we call the robotic stations, it can easily sense this. Okay. So once you have set this unit, so it will sense this wherever you are moving, and what we call the locking of the prism. Okay. So wherever you move, the station will also move. Okay. And then from here itself you can say you can give the command of measure the point. Okay. So it will automatically measure the point, provided this has not been having any obstacle in between. Okay. So unless and until this laser has been fired and it can move through, then there is no issue on that part. Okay. So that is what we call the new development having the robotic stations. And this picture which I am showing you is a robotic total station, which allows you to use it by having only one person. Okay. So further, if we look at that what I was talking about, that it usually measures. So this is your the prism, and that will remain your center of target. Okay. So most of the time this is your station here, and where you will give east north, that is your coordinates, and the height of the station is also to be taken into consideration. At the same time you will also have to take the height of the post. Okay. That is your right from the center of the prism, that we will take from this, you will take up to this. Okay. So that is the height of the prism as I have shown here. So this will be your HR actually. Okay. So that also has to be taken into consideration, and that has to be feeded to the CPU. Okay. Or you can say that at least to the microprocessor. So that will take as a reference. Okay. So this is one important part while setting the station. Of course, you have to level the 3 legs. Okay, you have to level it and to horizontal, and then you have to fix up your total station on the top of this. At the same time, this you have to fix up the height. Okay, depending on that how much is the obstacle in surrounding area. You cannot go for 10 meters height and all that. Okay, maximum you can put 2 to 2.5 meters or 3 meters, but mostly we focus and we try to confine ourselves in 2 meters of height of that. Okay, and this also again depends upon that how high what is the height of the person who has set up this total station. So these are some trivial points, but very important. Okay, because that may affect your overall measurements. Okay. So basically what this two, as I told, that HI, that is the instrument height, and then the rover height if we take, or maybe you can say the post height, that will be your center of target. So with respect to this, you are measuring this topography actually. So what you are taking is that horizontal angle, and then vertical, what we call the slope distance. Okay, that is also that what will give you that what is the difference in the. So as soon as the height changes, the slope of with respect to your station and the post will change actually. So theodolite measures your horizontal angle and vertical. Okay, vertical angle, that is your V. So this is what you are having, the horizontal angle and horizontal angle and the vertical angle of a line of sight from the center. Okay. So, this is again everything has been governed from the center of the station. So, this is your center here and as well as the center of the target actually. So, this you have to take into consideration. So, theodolite measures the horizontal angle and vertical angle of a line of sight. This is your line of sight actually. Okay. This is your line of sight. So, this which you are looking at is the line of sight. So, line of sight from the center of TS to the center of target on a point. So, this is your point actually, okay, of interest, that is your measured. So, if you then again if you move here, then this will be your interest point to be measured, and then center here will be your target center or center of target. So, the center of TS is at the intersection of rotation axis, okay, rotational axis of horizontal and vertical circle. So, earlier older like instruments which we were using for the measurements were not having this like vertical movement was restricted, okay. But in total stations, this is the advantage we are having, okay. So, the center of the target is the intersection of the axis of the center of the rod and the axis of tilting. Okay. Now, further we will see more points here. So, this is what has been explained in the previous slide also. Okay. So, basically what we are doing is we are taking the measurements in this circle as well as on the vertically we are also measuring in this circle. Okay. So, this vertical the horizontal will give you this angle, because you are not moving in the same line, you are moving at different points also. So, that will also be taken into consideration, as well as the vertical angle you will take, and that is your slope. Okay. So, that will also change depending on the elevation change here. Okay. So, further the your EDM instrument is built in a telescope to measure the slope distance. This is your slope distance, and that will vary depending on the height. Okay. And the slope distance is between the center of TS and the center of the prism, not the center of target. Okay. So, this is again and the important point we need to keep in mind about the slope distance. Okay. So, this is your slope distance what you are having. So, basically it is like the line of sight also, but you have to always carefully do that makes you getting the proper reading, that is you are looking at the center of a prism. Okay. Then CPU calculates the coordinates, that is easting, northing, and the h is your height. Okay. In a rectangular system, okay, of the point under the target with reference to TS coordinates. Okay. So, this has to be given first. Okay. So, what usually we do if we just want to take the reference points, so we usually do give 100, 100 or 1000, 1000, and with respect to that this will be obtained actually, the coordinates and the heights will be obtained when you are taking the measurements. But as I told that if you are using the reference point and a precise one, then you can enter this information over here in the TS, that is what is your coordinates and the height of that particular point. Okay. So, that will then whatever the measurements you are doing will be with respect to this. So, this will become a reference to your measurements. Okay. Now, there are a few more things which usually we take is that we, as soon as the station has been like established, we take one what we usually call the back point, backside point and all that, to have the reference for that, and then we start our measurements. Okay. So, this part we will try to explain you in the actual lab which we are going to perform on ground. Okay. So, this will help you in further understanding of what exactly we are doing and what we are measuring. Okay. So, this is what we will just look at again, that the CPU calculates the coordinates, that is east, north and h. H is your height in a rectangular system of a point under the target with reference to the TS coordinates. Okay. using the measured polar coordinates, that is your SD, HS, HZ and V. Okay. So, and the instrument height HI, this is your instrument height HI and target height HR. Okay, target height HR of the and the several correction factors and the constants which are been used to obtain the actual your east, west and northing. Okay. Because when we are measuring, this is the unknown point. Okay, this point is unknown. This is not known to the system. The system only knows that it has this coordinates, that is your station coordinates. Okay, so it knows that only. Even it doesn't know that what is the height, that is your DH. Okay, because this you will have to, in any case, will have to take into consideration when you are measuring. So you need to subtract this from the height, and even you have to take into consideration the HI when it calculates. Okay. So this, when feed it to the system, it will give you the exact coordinates. Okay. So this is what you are having in the triangular system, where you will get the east, north and H. Okay. Now further preparation, usually we require, like these are of course again very seriously, the points should be taken very seriously, because lot of or I would say that many such incidents have come across where we lost the total station. Okay, the main unit, and because of the carelessness or not having proper understanding of that. Okay. So TS usually is quite heavy, not so heavy, but yes, of course it cannot be just pulled on with one hand and all that. So need to be, so always take the best care following do and do nots as given below. Always carry the TS in locked hard case. This it comes with that. Okay, take the TS out of the case only beside a firmly set tripod. So this is your tripod. Okay, so once the tripod has been set to level, okay, then only you remove your TS from the box. Okay, before that it should not be removed and kept idle. Okay, then do not move or carry the tripod with TS. Okay, so sometime what happens, if you have to move the station, suppose you have set up this, the TS has been set up, total station has been set up. Now if you want to move this station because of some reasons where you are unable to look at your target center or the post, okay, or the prism, then usually we try to say that okay, let us shift this station here. Okay, and then we measure again. So but should not be done along with this actually. Okay, should not be done along with this. So this is, and use both the hands to hold the TS. So you need to usually take care of that. You are holding with two hands here. So one is picked up with this here, and another has been placed at down. Okay, so you just firmly use that. Okay, never release the handle before the TA. So there are more points which I think you can go through, but few I have explained are the most important one, and there are many more points which has to be taken into consideration before you start the measurements. Okay, so further equipment checklist is there, which you can do that. What you need to first move on. Okay, because and as I told that you need to set up the backside point and take the measurement. That will give you the reference point also. Okay, so like for example, this is the instrument what I was talking about, that it is the dissection of that, and this is a high resolution unit, and with this only we will give you the lab like demonstration. So for example, as I told that mostly we in our lab we are using to map the topography or the cross section of the river and all that. So this is one example from Kangra Valley, where we took the profile across this one. Okay, and this gave us the topography what has been seen here. So we have taken number of points. Now depending on the topographic break, okay, so once you because you can see the terrain ideally like when you are in field, so you may plan your survey. If you, this is the line line along which you want to take the measurements, okay. And as I told that it is not necessary that always you take the points in one line only. You can take points anywhere, okay. Since it is the station has been set, okay, it will give you the readings accordingly, okay. So now what my point here is that why you want to plan your survey here depending on this. So you need to first have a proper understanding of the landform here, and then depending on that you may reduce or you may increase the point surveys, okay. For example, if you see here, this is only one point which we have taken in the flat area, okay, or maximum you can take 2 points here. But as you have the topography, you can have more closely spaced points, okay. Now this will give you typical good handle in terms of the, so you may have the variation of 20 centimeter or 50 centimeter, depending on that you can do that actually, okay. So and RTK and PPK survey is the RTK is real time kinematic and this is post processing kinematics, okay. So you can even do the processing later on, but in RTK you have like 2 stations, okay. Like one has been set up anywhere, even you can set up over on the top of this, you can have the receiver on an antenna you can fix. Otherwise you can use the base here. You can have the antenna, one antenna here and another antenna as a rover which you can take, okay. Now this type of mapping, that is RTK and PPK, will not require your line of sight, okay, or the points where your total station fires the laser and you have to capture with your prism. That is not required, okay. So you just set up the one GPS over here, okay, and another you put as a rover here, and you keep moving, okay, depending on that what is the time frame you need and how many seconds you want to collect the data. So every 50 second or 1 second you want to collect, or 1 minute or so, but usually we usually keep 50 seconds or so we can have precise data. And then you need to hold this post precisely. Again, the height of this post has been given to the system here, and the height of the station also where the GPS has been put, that has also been entered here. So you keep moving and this will give you the points exactly what we are looking at, that is your x, y and z, okay. So this will also provide, and this you can have multiple points where you don't need to focus or connect with the total station, okay. So this is the advantage of RTK, and if you are covering a very large area, okay. So for example, this area which we did with the RTK, you can see the topography we were able to obtain was very precise, and we were able to even measure the displacement of this channel here, okay. So this is how you can generate, based on the triangulations, you can generate a very good digital elevation model, okay. So this you can do if you are doing RTK and all that, okay. Another example of this is from Kutch, that was from the earlier one. This was from Kangra Valley, where we used the RTK and generated this DM. Another one is from Kutch area, where we did in this particular area. This is the area which we mapped. This is the old settlement, ancient settlement we did, and the topographic or we can say the DM which was been prepared was something like this, okay. So this is the variation in the height of the area, and this allowed us to extract the topographic profiles as we have shown here, okay. So this is the advantage again of RTK, that you took like thousands of points have been taken, because we kept on walking here like this, okay, and very closely, and then further we moved like this also, okay, and that helped us in generating many points within very high accuracy, and that allowed us to generate this DM, as well as if you want to have the cross section here or topographic profile, you can say, okay, topographic, you can take this, or you can want to take at interval, given interval, that also you can do. Okay. And advantage, another one of this total station was that one can use for scanning the outcrops. Okay. So, this is the scanning which we did for one of the trench which was opened in Punjab. So, this is the exposed wall we have photographed and digitized completely. Okay. And also the we can map, because it has a laser which can continuously keep on measuring or recording this the topography of in vertical section also as in horizontal also. So, I will show the example of the C notch which we did with the total station here, and this was this is the total station which we used, and it has an inbuilt scanner also, what we call terrestrial scanner, and this helped us in preparing the overall the topography of the exposed trenches. Okay. And this helped us even to, because we took this from different angles. Okay. For example, one measurement was been done from here, another one was been done from here, and this was been merged actually. Okay. So, this allowed us to have a complete area and digital platform which we moved, and we also were able to measure the height here, that I will show here. So, this is the height which we have measured of this point here, which has been shown here. So, you get all the information what you require in terms of the measurement of the outcrop. Okay. So, this is the height of then we also confirm this locally by doing it manually. Okay, at the local site. So, this is the importance of this. Okay, the measurements which we can do with the help of total station, and also use the RTK and the terrestrial laser scanner. Okay. So, with this I will end up this lecture, and we'll see you in next lecture with the on either on OSL, or that is OSL dating part, or maybe we will look at the GPR point. Okay. So, I will stop here with this. Okay, and thank you so much.